Jose. We took a few days off, not off, but off of this to do completing the square and quadratic formula and factoring some more. So that's what you missed out on. So hopefully you've been practicing your quadratic formula, completing the square, and
going on hikes.
Factoring while you go on your hikes. Just kidding, I hope you're not. I hope you're just having a good time. Anyway, let's graph this sucker. Didn't we do this last Friday?
No, we didn't do anything last Friday.
Last Friday we had a work.
We sat there.
You graded us.
We did that last Friday.
We worked very hard last Friday.
Yeah, take two.
Anyway, so, okay, maybe it was Thursday when we started this last week, I remember. And then I graded your quizzes, and then I was like, oh crap, they don't know how to do this.
Because you graded our quizzes on Friday.
Oh, okay, that makes sense. Let's graph this. Just as a review, and then we'll continue on through the lesson and see what you remember. Let's see. When was the first step in graphing that?
Find the x values.
Be more specific.
The x points, or the x intercepts.
The x-intercepts, where it crosses the x-axis. How do we do that?
You take the x parentheses and then you add to the other side and then get x equals.
You cross the x-axis when y is equal to 0, right? That's going to happen all year for anything you ever graph. If you want x-intercepts, plug in 0 for y, and then solve the equation for x. Well, how do you solve a factored equation for x? Yeah, positive 4, positive 1, positive 8, that's where it is. I'm just trying to
I just don't remember how to.
yeah, you set each factor equal to 0. And then you add 4, so you get positive, these ones you can do in your head. You just get positive 4, positive 1, and positive 8. So we can put those points on the graph, right? When x is 4, y will be 0. 1, 2, 3, 4. When x is 1, y will be 0. And when x is 8, y will be 0. 1, 2, 3, 4, 5, 6, 7, 8. So we know those 3 points. What else do you know?
I just when x is positive, don't we make a u?
X is positive, we make a U.
Yeah.
It's a snake.
Yeah.
It's a snake-looking thingy?
Yes.
Yeah.
Oh, you're thinking about end behavior. That's what that's called. Like, what happens on the ends? Is it going to look like? Is it overall
Oh
going
no,
to?
I remember.
What?
Isn't it like when x is 2 or x squared?
X squared looks like a parabola always.
But
In general, it could have curves in the middle.
Wait, what's
And
what's
then
this wiggly one called?
And then the odd numbers are the
Cubed.
the backward x. No, the forward x.
I don't know. It might actually have like a real math name, but I don't know it. So.
It's a snake if
It's a
x
snake.
cubed.
All right.
Or any x odd.
But it could have squigglies in the middle if it's like x to the 5th. We'll talk about that in a second. But we know on the end it's going to go up to the right and down to the left, right?
Yes.
So we're going to just draw that in. Because we know x cubes always do that. And if I multiply this out, x times x times x, that's x to the 3rd. So we know this. Can we get the y-intercept? I'm about to draw this and I'm like, I want to know, like, does it cross down here, up here? How could we get a y-intercept?
Set x equal to 0.
Yeah. Wow. That's how it works. You probably never realized that in Algebra 1. Good old y equals mx plus b, remember that? What do you know about that? That's slope. What's that?
Y.
That's the y-intercept, right? Remember this?
Yeah,
Why is that the y-intercept?
because that's where
Does it
it crosses
intersect
the
with
line.
That's not
That doesn't
wrong.
make any sense. But okay, good.
It's the y-intercept because it intersects with 1.
Okay. But why is that? Why does that number tell you the y-intercept?
Because it's how much up or down you go.
Why?
Because that one's the
That's
x.
how it works.
Because
Why
that
is
one's
what we're
x.
looking for?
Yeah.
Yeah.
Do we just
Here's the real answer. Because when you cross the y-axis, what is the value of x?
0.
0, it's 0 comma something, right? And if I plug in 0 for x in this equation, 0 times anything is still 0, and all that remains is this. So y will equal that when x is 0. Ah.
It's just, or couldn't we just do if y equals
So,
x minus
something like this, you just let x equal 0,
4?
and you'll figure out the y-intercept. So that would be 0 minus 4 times 0 minus 1 times 0 minus 8. So basically we got negative 4 times negative 1, which is 4 times negative 8 would be negative 32.
Oh.
So it's way, so, dude, that's like skinny. It's like way down there. This one probably goes up a lot steeper too. I was just throwing that out there. That's like future stuff.
How much does it snake?
How much does it snake? Well, we could draw it in. It's obviously going to go like this.
Well, yeah, but
The book tells you a different way to do it. They're like, check the sign between 1 and 4. So the way you would do that, you have this thing. I'm just going to get rid of this. Have you ever seen this notation?
yeah.
Hopefully you saw that in Algebra 1. You weren't there? Well, hopefully you know that's just like a y. It just means f is a function. Maybe we'll talk more about it. You know what this means if I were to go like
Because
this?
then you put like x equals 2, and so then you just put 2 in for all of the x's.
Yeah, you plug in 2 for x. That means plug in 2 for all these x's.
Yeah.
That'll give you the value of y when x is 2, right? So it's just like making a table. I plug in 2 for x, I see what y is, and I can put a dot. Well, we're going to kind of do it, but not completely. This is just another way to... If I did 2 minus 4, that would be a negative number, right? And if I did 2 minus 1, that would be a positive number. If I did 2 minus 8, that would be a negative number. What's a negative times a positive times a negative?
Negative.
Positive. Negative times positive is negative. Negative times... Just look at the negatives. 2 negatives, a negative times a negative is positive. So that's just a quick way of reassuring me that when x is 2, this thing is going to be up here somewhere.
How much does it go?
It's not going to... How much? We would actually have to calculate it. 2 minus... We're not going to do that right now. You could do 2 minus 4 is negative 2, 2 minus 1 is 1, 2 minus 8 is negative 6, negative 2 times negative 6 is 12. So it goes clear up to 12. It goes way up there. We're just going to do a sketch. We're just going to be like, hey, it goes like this. Hey, we don't have a scale on our y-axis. Can't say that's wrong. Maybe that's 12 right there. I don't know. So, yeah. Obviously now, there's only one thing that can happen here. It's going to go down here and then come back up through there, right? We're just doing sketches. Okay, let's move on. Next page gives you graphs. Gives you three functions, f, g, and h here. Remember, the letter is just like a name tag. It doesn't really mean anything. It's not g times x. It just means it's a way to distinguish between three different ones. Instead of all y, we can be like, hey, this is graph f, this is graph g, this is graph h. Remember that?
Yeah.
Okay, just checking. Your full history. So. The degree of each polynomial, what does that mean? Any ideas? It's like, is it hot or cold? It's not that. It's if you multiplied it out, what is the highest power of x? That is the degree. So like this one would be a x squared, or just 2 is the degree, the highest power of x. What's this one? X times x times x is x to the third. And this one, x to the fourth. Number of x-intercepts. How many x-intercepts does that have? 2. X. 1, 2, right there. How many does that one have? 3. How many does that one have? 1, 2, 3, 4. Interesting. Number of relative maximum and minimum points shown in each graph. That's new. We gotta do some like vocabulary words. What relative maximum and minimum means.
That just means how far up it can go and how far down it can go, right?
Kind of. They're talking about like the hills and valleys. like these points. They say relative because like on this graph, that point is not the maximum point the graph reaches. It goes farther out here. But if I just look at like this area, this region, that's the maximum point. So that's why it says relative, because it just means like the area around it, that's the highest point. Basically just hills and valleys. So how many relative maximum or minimum points does this have? One. It comes down, it's like about right there. There's one valley, right? How many does that one have? Two. There's the high point here and there's a low point here. Three. A low point, a high point, and then another low point. What observations can we make from this information?
Same numbers, one less.
Yep, same numbers, one less. X-intercept is going to be the same. If it's an x squared, it might be 2 x-intercepts. I'm saying might, because when we go down here, it says, is this true for every polynomial? Here's this one. The degree is 2 again. X squared times x, the degree is 3. X, the degree is 4. But look how many x-intercepts there are. 0. Only 1. Only 2. That's weird. Let's look at max and minimum. That one has 1 again. That one has, how many, you see any hills or valleys? 0. It just kind of swerves through. It never turns around. It never goes high and then back to low, or low and then back to high. There's no.
Why not?
This one has 1. Yeah, right here. 1, and then it just goes up forever. I like, what observations can we make from this information?
We were wrong.
We're not wrong.
Well, we were.
All this means is the degree tells you the maximum number of x-intercepts and the maximum number of hills or valleys.
Okay.
It may have less. Like you could have 0 x-intercepts for an x squared. You could have 1 x-intercept, or you could have 2, but you cannot have 3. For an x to the third, you could have 0, 1, 2, or 3 x-intercepts, but you can't have more. It just tells you the maximum number. If it's an x to the third, you're going to have at most 2 hills or valleys. You're never going to have more than that. You might have 0, but you're never going to. It's never going to turn around 3 times like that, like 1, 2, 3. That'll never happen. So it just tells you the maximum number of curves and the maximum number of x-intercepts. Does that make sense? Moving along. Hey, look at relevant vocabulary. We need vocabulary in all classes. We're going to do some problem set ones real quick. We're not going to follow the directions, and we're not going to actually graph it. Just look at F, G, and H right here and tell me the largest number of x-intercepts it could possibly have and the largest number of relative max and mins it could possibly have. That should take around 12 seconds. Go. Maybe not. I'll do one for you. F, what's the maximum number of x-intercepts?
4.
Okay. It's actually 3. Look at the highest power of x only. 3. What's the largest number of relative max and mins? 2. It's always 1 less. And if you think about it, it makes sense because if you're only going to cross the x-axis 3 times, the most times it'll turn around is 2. If you turn around again, you probably hit it again. So all you're looking at on these is the highest power of x. Ignore the rest. Got them all now? What's this one? 7. This one? 6. This one? 4. 3. Easy. And then you could graph it, you could see the actual number, but then it's like, whoopity-doo. It's never going to be higher than this, but it might be lower, so whatever. Next. Think you could graph that?
No.
No? Okay, no.
I mean, we might as well because you're supposed to do
Well, I'm just saying, could you do it on your own without me saying anything?
Let's try.
Do your x-intercepts, figure out what happens at the ends, and then this thing says, determine the sign of the values of the function between zeros. You know what that means? It's like we did on the last one. You would pick a point. I didn't explain that. I remember. When I did this one and I did f of 2, the reason I chose 2 was because it was between these x-intercepts. 2 is right here. I could have chose 2 or 3 to figure out something between them. That's what that means when it says determining the sign of the values of the function between zeros. It just means between two x-intercepts, figure out the sign. You can kind of figure it out just by drawing the dots and knowing what happens in the end and snaking through it. But if you can, I don't know. Got your x-intercepts? No? How come?
Multiply the half to all.
You do not.
You only did the first one.
The half does not affect your x-intercepts. To get x-intercepts, plug in 0 for y and set each factor equal to 0. If you did a half equals 0, that's one of the factors. That's nothing. That's inconclusive. It doesn't. So your x-intercepts
-5.
are just -5, -1, +2.
It's gonna be a snake.
It's gonna be what's gonna happen at the ends?
Yeah, it's gonna snake.
At the ends.
Yeah, one up, one down, because it's
Which one up and which one down?
Right side.
right side up, right side, or left
Right side up, left side down. That's if it's positive. If you have a negative in front, it flips it,
Oh,
which you're going to see on the next one. They're going to throw a negative in front, then it would be up on the left, down on the right. So once you know that, you could pretty much figure out the rest without plugging in a number to determine the sign. You might say, well, it might bounce off of here, but remember I told you what happens? It's only if one of the factors is squared, then it bounces off. If you don't remember that, in the future, you might have to plug in some numbers. You might have to be like, well, I'll pick -2, plug it in, and just check the signs. If I do f of -2, and plug it in, -2 plus 5 is positive, -2 plus 1 is negative, -2 minus 2 is negative, positive, negative, that's positive. So it's going to be positive up here. It's going to go. That make sense? And then obviously that we could get more accurate. We could figure out the y-intercept like we just showed you. Like I just showed you. No need right now. Oh, you're going to have to do that on 5. Just deciding how much more I'm
We
going
have 10 minutes.
to 10 minutes? 10 whole minutes? So you could probably try number 3. You don't need another example, do you? Number 4. Look at number 4, though. What are you going to have to do? How are you going to find the zeros of that?
Plug in a number.
You got something? No?
x equals 0.
That'll give you the y-intercept. Plug in 0 for... What? What's the y-intercept of this? 2. If you plug in 0 for x, right? When you cross the y-axis, x is 0. Plug in 0 for x, 0, 0, 0, 2. Hey, I know a point. That's cool. What about x-intercepts? How does this one look different than the ones we've just already done? They're not in parentheses. Could we make it become in parentheses?
Yeah.
And what is the process by which we do that called?
Grouping.
Oh, grouping for this one. I was just gonna say factoring. Yeah. You gotta factor first. Then you'll have your factors. Then you can get your x-intercepts. Good thing we know how to factor. 5, you don't have to factor because 1, you don't know how to factor that. But look, it tells you the zeros. It tells you that zeros means x-intercepts. It's the same thing. But this one, notice there's only 3 of them. If there's only 3 x-intercepts and this was to the 4th power, what do you think is going to happen at one of them?
It's gonna do
Bounce
that.
off.
It's going to bounce off of it. One of them is going to be one of the factors, like, you know, your factors would be like x plus 1, x minus 1, x minus 3. One of those, I don't know which one, would be squared. Because you have to get up to x to the 4th. But since I don't know which one, how can we solve that issue? You're going to have to check the signs between zeros. So you're going to have to go put your x-intercepts on there. -1, 1, 3. I don't want to do that. It takes so much time. Let's do it. Let's continue. I'll just do it for you. What I mean by that is, well, you know it's x to the 4th, so you should know what happens at the ends.
Goes up.
And yeah, it's not negative. If there was a negative at x to the 4th, it would go down. But you know at the ends, since it's positive x to the 4th, it goes up, up. But now we just got to figure out which one does it bounce off of. So how could you do that?
Why do they both go up?
Because it's x to the 4th, and even powers always look like parabolas at the end. How could I know, does it go down through here like this, or does it bounce off of it and come back up? Check the sign. How could we do that, Charlie? Plug in a number. What number should we plug in?
2.
2? Well, no, 2's over here. How about 0? If we plug in 0 for x, won't that tell us whether to bounce off or go down here? Plug in 0 for x. 0, 0, 0, 0, -3. F of 0 equals -3. Hey, we might as well just put the actual point on the graph. Now do we know? It goes through and comes up. Well, this one we don't need to check, because if you're thinking ahead, you know what's going to happen. But if you're not thinking ahead, let's plug in 2. That's going to be a lot of work, though. So we have to go 2 to the 4th. It's not like easy like the factored ones, where you can just get the sign and then multiply them together. Because this one you have to like actually plug it in and do it all. But if you think ahead and you go, hey, look at this is an x to the 4th. One of these needs to be squared. I guarantee you it's going to bounce off of that one and then go up through there. It has to. And I guarantee you if you plug in 2 for that, you'll get a negative something. Not -0. Negative something.
This is so
Weird?
weird.
What do you mean weird?
Weird.
Graphing is going to be the easiest thing of your life after this.
This is gonna be the easiest thing you do.
Yeah.
What?
Yeah. It's all easy if you know how to do it.
You only have 6 minutes.
We only have 6 minutes? Well, then you only have 3 homework problems.
What?
I'm not going to give you homework over break. Come on. We got to
3,
get
4, and what?
as much as we
So much
can.
homework.
Wait, 3, 4, and what?
3, 4. Oh, I just put 3. Okay, sorry, you're 4. 3, 4, 6, 7. 7, if you don't know, I can forgive you.
Didn't one of your classes have to do this? Like maybe video or something?
Yeah. You need to make your own video of yourself
Yeah,
kicking
'cause
them.
they're like all saved on so many computers.
Oh, you've seen them?
Yeah.
Yeah, we can do it.
Oh.
It's kind of fun. You get to make a video of yourself, like they were all like throwing something in the
It's
air,
bouncing, oh yeah.
bouncing a ball, and then you track the motion of the ball, and you figure out the equation for the time
My King
versus
Rodrigo
the
threw a
height.
backpack.
Yeah, he threw his backpack and then like went outside, chucked his backpack and it flew, and then you use this computer program to track it, and you get the equation of the problem, you do some different stuff, and you answer questions.